Welcome to T1 Academy. In our last sessions, we discussed about the number system which is related to CSAT from the completely CSAT perspective, right? And we also solved some of the previous year's questions as well as some practice questions from the concept called number system. So in this session, we are going to learn about permutations and combinations, which is very important from CSAT perspective. Why? Because students, they are asking questions in such a manner that those questions are linked to the number system as well as permutations and combinations. If you are really good in these permutations and combinations, you can solve some of the questions from number systems very easily. Okay, keeping that thing in our mind, so what we decided is immediately after number system, we will learn these permutations and combinations, and after learning these permutations and combinations, then once again we will solve some of the questions which are related to these number systems and permutation and combination, so that the entire number system concept will be finished. Okay, right. Now we will see this permutations and combinations concept. What actually is this permutations and combination means? See here students, the word permutation and combination. This is the technical term. If these are the technical terms, what we can say is permutation is nothing but arrangement. Okay. Whenever you want to arrange something, there we will apply the logic of permutations. Combinations is nothing but selection. Whenever you want to select something from a group of people, then we will take their selection or sometimes choosing. Okay, depending on the situation. They anyway both are same, selection or choosing the people, both are same. Now see here what is meant by this arrangement. We will take with an example. Okay, for example, if I have eat, there is a word eat. If I want to arrange this word eat, in how many different ways we can arrange the letters of the word eat? I can write it as EAT, eat, or else ETA, or else AET, or else ATE, or else TAE, or TEA. These are the different ways which we can arrange the letters of the word eat. Understood students? We can arrange that in 6 different ways. We can arrange the letters of the word eat in 6 different ways. Okay, in general this is a 3-letter word, so we have taken our time and we have written all the possibilities, and we said finally that the letters of the word eat can be arranged in 6 different ways. But in general what happens in the examination is they will not give us a 3-letter word. They may give us a 6-letter word or 7-letter word or 8-letter word. We cannot write all the possibilities like this, right? It will waste a lot of time for us, and sometimes we may miss some possibilities also. To avoid this confusion, we will use the concept of permutations. We will use the concept of permutations. That means with the help of permutations concept, we will tell that in how many different ways we can arrange the letters of the word eat. Okay, this is called permutations in general. Later we will see the procedure and all the remaining things we will see next. But as of now, this is called the permutations. Next, when it comes to the combinations. When it comes to the combination means just now I told you selection. For example, there is a bag. There is a bag. This bag contains a red color ball, a black color ball, and a white color ball. If I want to pick any two balls from this one, in how many different ways I can pick? I can pick red, black, or else I can pick red and white, or else black and white. These are the 3 possibilities for us, right? These are the 3 possibilities for us. See here students, the major difference between this permutations and combination, one more major difference is, in permutations, which letter we are writing first, which letter we are writing next, and which letter we are writing last. That is very important. That means the order is very important in permutations. The order is very important in permutations. When it comes to combinations, there is no rule that first I need to pick red ball, next black ball, until and unless they mention in the question. Until and unless they mention in the question, we will not follow that rule. Generally, if I want to pick a red and black means we will pick red and black. We will not see whether black color ball pick first or red color ball pick next. Simply we need to pick red and black. Similarly, we can pick red and white or black and white. Like this, we will see the observation. So in how many ways I can select them? In 3 different ways I can select them. So to do the selection, we will use the concept of combinations. To arrange the things, we will use the concept of permutations. Understood students? Okay, this is the basic idea of permutations and combinations. Permutations means arranging the things. Combination means selecting the things or choosing the things. So, depending on the situations and the problems, we will solve the remaining. Next, see here students, what is this case is? This case is without repetition. Without repetition. What is meant by this without repetition? Means see here, I cannot use the letters for multiple times. E I can use only for one time, A I can use only for one time, T I can use it only for one time. For example, if repetition is allowed, what I can do is I can take all 3 letters as E, or else I can take all 3 letters as A, or else all 3 letters as T. So, this case is called as when repetition is allowed, when repetition is allowed and without repetition. See, generally students, in our cases, in most of the cases, the questions will be based on without repetition only. Very rarely we will see with repetition. When with repetition comes, that is only the application oriented types of questions. We will see those questions. But generally this is without repetition. That means the letter of E we can be used only for once. Okay, like this. Now, the shortcut for this is, see students, there are 2 ways to solve the problems from these permutations and combinations. One is with the help of formula and the other one is with the general procedure. Means standard procedure. In most of the cases, we will try to solve the problems with the help of general procedures. If it is required, then we will go for the formula. Understood? Now, just now we have taken example eat, right? Eat. How many letters are there? Actually, for me, 3 letters are there. So, please see here 1, 2, 3. First position, second position, third position. I have 3 positions here, first, second and third. Now, in the first position, all the 3 are available for me, right now. Why? Because I can put any letter here out of those 3 letters. So, how many chances are there for me here? These are chances, students. Okay, these are chances. For the first position, how many chances are there for me? 3 chances are there. Now, for the second position, see here students, already out of 3 letters, 1 letter was filled here. 1 letter was filled here. So, for the second position, how many chances do I have here? Actually, 2 chances. Why? Because already 1 is filled here. Now, out of the remaining 2, I need to fill 1 here. Okay. Now, when it comes to the third position, how many chances will I have? When it comes to the third position, I will have only 1 chance. I will have only 1 chance. Why? Because out of 3, already 2 were filled. So, I will be left with 1 chance. So, the number of chances 3 into 2 into 1. So, that means in how many ways I can arrange the letters of the words? In 6 different ways. Already we have seen what are those 6 different ways. Okay, generally this is the standard procedure, students. I mean basic with the basic idea we can solve the problems. We are going to use this concept a lot to solve our problems. This is without repetition, right? This is without repetition. That means E can be used once, A can be used once, T can be used once. Now with repetition, what happens if the same thing is with repetition for understanding? First position, second position, third position. Now, out of 3 letters, I can use all the 3 in my first position. Yes, I can use all the 3. When it comes to second position, now repetition is allowed, right? If E is used at first position, once again I can use at second position also, right? So, how many chances will be there for me second position? All the 3. For the third position also, I will have all the 3 chances. So, now what I can say? 3 into 3 into 3, which is equal to 3 cube. Which is equal to 3 cube. So, this is with repetition is allowed here. Repetition is allowed here, and here repetition is not allowed. Repetition is not allowed or without repetition So, this is the basic method to solve the problems using this one. Okay, sir, good. See here students, this one 3 into 2 into 1, this is nothing but 3 factorial. This is nothing but 3 factorial. So, whenever there are different letters, so directly count the letters and use the factorial concept. Use the factorial. Okay, this is with the help of our problem, formulas and all those things. Now, for this we have one more thing with the formula. How we can solve the same thing with the help of a formula, permutations formula. What is the permutations formula which we have is NPR. The permutation formula which we have here is NPR. NPR is equal to n factorial by n minus r factorial. NPR is equal to n factorial by n minus r factorial. NPR is equal to n minus r factorial. So, this is the formula for our permutations. This is the formula for our permutations. And what is this formula and all those things we will see next. Okay. by substituting. For example, the same thing I want to substitute in the formula. How many letters are there for me? 3 letters are there. How many places are there for me? How many positions are there for me? 3 positions are there. So what is the formula you are going to use? 3p3. 3p3. So what happens to this one? 3 factorial by 3 minus 3 factorial. We already know that 3 factorial by 0 factorial means what? 1. So which in term becomes what? 3 factorial. The same thing. So whether you go with the formula or with the general procedure, we will get the same answer, students. Okay, but what my suggestion is, always we will try to solve with the help of general position. Why? Because we can easily understand the questions. If you once understand this, we can easily understand the questions or concepts, and then we can easily solve the difficult questions. Okay, you should have idea on both this general procedure as well as formula. Okay, right now we will see some formulas and then we will see. For time being, forget about this formula. Just observe this above formula. Permutations. Out of n different positions, R elements can be arranged in first case without repetition. Without repetition. When there is no repetition, in how many different ways we can do? NPR ways. Just now we have seen. Okay. When with repetition means when repetition is allowed, R to the power of n. 3 cube we got right earlier. That is the case of 3 cube. Understood? So we will use two formulas, NPR and R to the power of n, very rarely. In most of the cases, we will try to solve them in a general process, how we have solved our previous case. Understood, students? Now we will move to our problems directly and we will see all the different cases. Now see here the first question. In how many ways the letters of the following words can be arranged without repetition? Okay, this question is without repetition. That means the letters should not be repeated. Now first example, see here money. How many letters are there? 1, 2, 3, 4, 5. So how many positions I will get? 5 positions. 1, 2, 3, 4, 5. 5 positions are there for me. So first position, second position, third position, fourth position and fifth position. Okay, right. Now see here, for the first position, out of these 5 different letters, all the letters are different letters, right? Is any letter repeated in this one? No letter is repeated, so no problem. Directly. For the first position, how many chances do I have? I can place any of the 5 letters which are available for me. Okay, among M, O, N, E, Y, I can place any one of them. Next, when it comes to second position, how many chances I will have? 4 chances. When it comes to third position, how many chances I will have? 3 chances, 2 and 1. Why? Because slowly it will be in a decremental order. Why? Because each place will be occupied, right? So now total number of ways means what it becomes? 5 into 4 into 3 into 2 into 1, which will become what for us? 120. Why? Because this value is nothing but 5 factorial. See students, try to remember at least up to 6 factorial or 7 factorial, which will be helpful for us while solving the problems. Okay. Right. So money can be arranged in how many ways? 5 factorial ways. So directly count the number of letters. If nothing is repeated, directly write 5 factorial. Now similarly, please observe this one, travel. 1, 2, 3, 4, 5, 6. How many letters are there for me? 6 letters are there. So I can arrange the letters of the word travel in what? How many times? In 6 factorial ways. In 6 factorial ways directly. No letter is repeated. We will see. Later we will see if letter is repeated, what will happen. In the next slide, we are going to see that one. Okay. So now please pause the video and try to solve these 2 things. For coat, we can arrange the letters of the word coat in how many different ways? 4 factorial ways. Similarly, the combine 1, 2, 3, 4, 5, 6, 7 in 7 factorial ways. Similarly, education 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letters are there. So I can arrange the letters of the word education in 9 factorial ways. 9 factorial ways. No letter is repeated in all these examples, students. Now this question is actually related to what? Without repetition, right? Now for your understanding, we will write with if repetition is allowed. That means with repetition. What will happen for the same things? We will see for a while. So money can be written in how many ways? 5 to the power of 5 ways. What is the reason? For all the positions, I will have all the 5 chances. Right? For all the positions, I will have 5 chances. So then it will become what? 5 to the power of 5. And similarly for travel, it will become what? 6 to the power of 6. Why? Because for all the 6 positions, I will have all the 6 chances. For coat, what I will have? 4 to the power of 4. For combined, what I will have? 7 to the power of 7. For education, what will be my answer? 9 to the power of 9. But with repetition is very, very rare case, students. Very rarely they will ask questions from this with repetition, and that too in an application oriented they may ask us. Not in this type, they may ask us in an application oriented. I think in 2021 or 2022, they asked the similar question. In how many ways the letters of the word Delhi can be arranged? Think in 2021, I think so. 21. In how many words, in how many ways the letters of the word Delhi can be arranged? See here 1, 2, 3, 4, 5. How many letters are there in Delhi? 5 letters are there. So, the letters of the word Delhi can be arranged in 5 factorial ways. 5 factorial ways. So, our answer will become what? 120 there. 120. Okay. Like this, they are asking questions from this concept. Okay. We will see next. In all these examples, no letter is repeated, right? Right. Next one. See here, in how many ways the letters of the following words can be arranged without repetition? Now, but see here, caller, L was repeated for 2 times. Earlier in the previous slide, we solved some examples. There no letter was repeated. But in this case, one letter is repeated. So, what we will do is, as usual, for example, students, we will take one simple example and try to observe here. I is there. I is there. In how many ways I can arrange the letters of the word I? I can write EYE, or else EEY, or else YEE. In only this many ways, right? I can arrange them only in 3 factorial ways. Sorry, 3 ways. I can arrange them only in 3 ways. What is the reason? Why? Because 2 letters are same. What is that letter? E. 2 letters are same letters, that is E. So, at max I can arrange the letters of the word EI in how many ways? 3 ways. 3 ways. So, the actual reason behind that is 1, 2, 3, okay, 3 factorial, by whenever repetition is there. E was repeated for 2 times, so by 2 factorial. By 2 factorial. If there is any repetition, immediately we will have the denominator. If any letter is repeated in the given word if letter is repeated, not about the repetition case. In the given word, if any letter is repeated, then immediately we will have a denominator. So, what happens now? See here, 1, 2, 3, 4, 5, 6. In general, what we will say? 6 factorial. But here, the letter L was repeated twice, so we are going to take by 2 factorial. Understood? Why? Because the letter L was repeated twice. Now, similarly, what will be the answer for gratitude? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 are there, 10 factorial by. Now, please observe here, which letter is repeated? T was repeated for 3 times. So, by 3 factorial. 10 factorial by 3 factorial. Why? Because the letter T was repeated thrice. So, we will write it as 10 factorial by 3 factorial. Next, horror. How many letters? 1, 2, 3, 4, 5, 6 are there. So, 6 factorial by. Please observe here, students. Here O was repeated for twice and R was repeated for thrice. Don't add 2 plus 3 and write it as 5. Write them individually. Write them individually. So, O was repeated for twice. So, 2 factorial. R was repeated for thrice by 3 factorial. Don't combine them. Don't combine them. Okay. Write them separately. Similarly, see the corporation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there. 11 factorial by. Is there any repetition? Yes, there are repetitions. What we have? O was repeated for 1, 2, 3. 3 factorial. Next, R was there for 1, 2, 2 factorial. Next, is there any other word repeated? No, that's it. Only O and R are repeated, no other letter is repeated. So, 11 factorial by 3 factorial into 2 factorial. Now, when it comes to engineering, what will happen to this engineering? We will see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Total 11 letters are there for me here. So, 11 factorial by. E was repeated for thrice, so 3 factorial. N was repeated for thrice, so 3 factorial. Next, G was repeated for twice, so 2 factorial. Next, I was repeated for twice, so 2 factorial. So write them individually, don't combine them. So 11 factorial by 3 factorial into 3 factorial into 2 factorial into 2 factorial. This 3 is for E, this is for N, this 2 is for G, and this is for I. So if any letters are repeated immediately, not only in this case students, in any other case also, whenever there are repeated letters, immediately we will have the denominators. Remember this one. Whenever we have repetition of letters in the given word, if repetition is there, then immediately we will have the denominators. Not the case of repetition is allowed. Okay, understood? So if in the given word, if any letter is repeated, we will have the denominators. If in the given word, if no letter is repeated, very happy, directly we will count the number of letters in that word and we will write that factorial. If the letter has some n number of letters, if the word has some n number of letters, means our answer becomes n factorial, right? Like this we are going to solve the answer. See here students, and one more thing, anyway we are here. So especially in the case of factorials, if you want to cancel, if you have something like this 10 factorial by 5 factorial, please don't cancel this and write it as 2 factorial. This is wrong. These are factorials. Please be careful. Don't cancel them like this. That is a blunder. Instead of that, what you can do is 10 into 9 into 8 into 7 into 6 into 5 factorial. You can write it as 5 factorial by 5 factorial, and now you can cancel 5 factorial with 5 factorial. But don't please cancel that with 5 factorial 1s, 5 factorial 2s, like that. Don't do it. That is a mistake. So you should not do that. Okay. How you can cancel means when the factorial values are equal, then you can cancel them. Else you should not cancel them. 10 factorial, what I have written like this, up to 5 factorial and 5 factorial, you can cancel at that point. But you should not cancel it priorly. Okay. Next one. In how many ways the letters of the word tongue can be arranged such that always the vowels come together? This is different question for us. Now see here, there is a word tongue. What they are telling us here, we should arrange the letters of the word tongue such that always my vowels should come together. So first of all, what are the vowels which have in this tongue? O, U, E are the vowels which we have in the tongue. Okay, vowels. What are the vowels in English alphabets? A, E, I, O, U. A, E, I, O, U are the vowels which are there in our English alphabet. So they are telling that vowels should come together. Now what will happen? See here, T, N, G are the consonants which I have here. So I have made vowels as a group. Now what they are telling is, whenever they move, all the vowels should move together. So to happen this, what I will do is, I will consider this vowels group as a single alphabet. So that they can move as a group. No one will move individually. So now what happens? 1, 2, 3 and 4 letters are there for me. Actually 6 letters, but I have made these vowels as a single group. That means whenever they move as a group. So 4 letters can be arranged in how many ways? 4 factorial ways. Next, once again, inside this vowels group, they can shuffle internally, right? That means why only OUE should be there? EOU can also be there. UOE can also be there. They can shuffle internally in how many ways? 3 letters can shuffle internally in how many ways? In 3 factorial ways. So our answer will become 4 factorial into 3 factorial. 4 factorial is 24, 3 factorial is 6. 24 6 are 144 ways. That means we can arrange the letters of the word tongue in such a way that all the vowels come together in 144 ways. Understood? What I have done, once again I am repeating. Why? Because later we will do some more examples. I have written all the consonants and I have written vowels as a group. Why? Because they should come together. Now it became how many letters? Only 4 letters. Now these vowels can internally shuffle. Yes, they can internally shuffle. They can internally shuffle in 3 factorial ways. Right? Next one. Now please try to solve these questions, students. Pause the video for a while and try to get the answer for this. In how many ways the letters of the following words can be arranged such that always the vowels come together? Just now I told you how to solve this one. Please pause the video and try to solve them. So first of all, write the consonants. What I have? C, H, M, N, Y. and the vowels I have here is I and E. So 1, 2, 3, 4, 5, 6. 6 letters are there for me. So 6 factorial. This I and E can internally be arranged in 2 factorial ways. I and E can internally arranged in 2 factorial ways. These are vowels. Vowels arrangement. Vowels arrangement. This 2 factorial is vowels arrangements. Next, carpet. What I have? C, R, P, T. A and E are the vowels I have in this one. So 1, 2, 3, 4, 5. So total 5 are there. This one I am considering as a single letter. So 5 factorial. A and E can be internally arranged in or shuffled in 2 factorial ways. Okay. Next, learn. L, R, N, E, A. 1, 2, 3, 4. 4 factorial. E, A can be internally arranged in 2 factorial ways. Next, education. D, C, T, N, E, U, A, I, O. E, U, A, I, O. So 1, 2, 3, 4, 5. So 5 factorial into this 5 vowels can be arranged internally in 5 factorial ways. 5 vowels can be arranged internally in 5 factorial ways. Next, marble. M, R, B, L. A and E as a group. So 1, 2, 3, 4, 5. So 5 factorial into A and E can be internally arranged in 2 factorial ways. A and E can be internally arranged in 2 factorial ways. In this manner, we are going to solve the problems. Understood, students? Vowels coming together means this is the case. And all the examples what happened here is, here no letter is repeated in the given letters. So now if letters are repeated, same procedure, but we will have the denominators, that's it. Now see here, vowels come together. This is also the case of vowels should come together. What will happen? Vowels coming together. Now what we will do here is the same thing, carrot. So what we are going to write? C, R, R, T, A, O. 1, 2, 3, 4, 5. So 5 factorial into A and O can be arranged internally in 2 factorial ways by R was repeated for 2 times, so 2 factorial. Okay, whenever there are letters are repeated, immediately we will have the denominator, but the procedure remains the same. There will be no difference in the procedure. Now, terrible. T, R, R, B, L, E, I, E. Please be careful, students. You should write all the letters. Please count it once again. Total how many are there? 8 are there. So here also I got 8. Now 1, 2, 3, 4, 5, 6 letters. 6 factorial into EIE can be internally arranged in 3 factorial ways by R was repeated for 2 times and E was repeated for 2 times. So 2 factorial into 2 factorial. 2 factorial into 2 factorial. Understood? Next, presentation. Same. PRS, presentation. PRS N. PRSN, T, T, N. What are the vowels I have here? E, E, A, I, O. E, E, A, I, O. E, E, A, I, O. Okay. So now 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial into 1, 2, 3, 4, 5. 5 factorial by, now repetition. Please see here, N was there for 2 times, T was there for 2 times, so 2 factorial, 2 factorial, E was there for 2 times, so 2 factorial. Okay. So simply we will write the denominators. Next, preparation. What we will have? P, R, P, R, T, N. P, R, P, R, T, N and E, E, A, I, O. So 1, 2, 3, 4, 5, 6, 7. 7 factorial into this one internally can be arranged in 5 factorial ways by denominator. P was there for 2 times, so 2 factorial. R was there for 2 times, 2 factorial. E was there for 2 times, so 2 factorial. Okay. Like this we are going to solve the questions from this. Vowels come together. Vowels come together. Okay, good, superb. Next consonants come together. See, similar one, right? In the case of vowels come together, what we have done? We have written first consonants and we written vowels as a group. Now here the case is consonants should come together. That means what you need to do? First you need to write vowels and then write consonants as a group. That means what happens here for me? AE we will write and I will write WTR as a group. WTR as a group for us here. Okay. So now what happens to this? 1, 2, 3. 3 factorial into WTR can be internally shuffled in 3 factorial ways. Internally shuffled in 3 factorial ways. Why? Because they are 2, 3 different. Is there any repeated? No repetition, so no denominator. Next animal AI, A, NML. So 1, 2, 3, 4. 4 factorial into 3 factorial by, here A was repeated for 2 times, so 2 factorial. Next color, what you will get? OOU, CLR. 1, 2, 3, 4. 4 factorial into 3 factorial by 2 factorial. Why? Because O was repeated for twice. And similarly try to write the answer for cricket. You will get the answer. What is the answer you will get for cricket? Total IE is there, okay for me. CRC KT. CRC KT. So 1, 2, 3. 3 factorial into 5 factorial. They can be internally written in 5 factorial ways by C was there for 2 times, so 2 factorial by 2 factorial. So in this manner we will write vowels come together or consonants come together. If they give us any logic, special logic like this, we will do like this. Okay. Next one. In how many ways the letters of the following words can be arranged such that all the vowels should not come together? Okay, such that always the vowels should not come together. This is very, very important, students. Vowels should not come together. How we can solve this problem? How we will solve this problem means, see here, not coming together means, not come together. What we can do is, we can find it in a reverse order. Reverse order in the sense what? Total dimensions minus always come together. We will get the same thing, right? Total minus always come together. Actually, we don't have a special formula or special procedure for it. Instead of that, what we will do is, not come together means we will find the total chances, that means in general, without any condition, the total number of ways we can do, and minus always come together. Minus always come together. We know how to find the total number of chances and we know how to find always come together chances. Right? Now please see here, first chimney. Chimney. Total number of chances 1, 2, 3, 4, 5, 6, 7. So 7 factorial ways is total, minus always come together. Vowels come together means what you will write? First CH, M, NY, I and D as a group. I am writing vowels come together cases. 1, 2, 3, 4, 5, 6. So 6 factorial into I and D can be internally shuffled in 2 factorial ways. So 7 factorial minus 6 factorial into 2 factorial. Understood, students? What we have done here? Okay. Chimney. So when you solve it, what you can write this one? Please observe here. 7 into 6 factorial minus 2 into 6 factorial. 7 into 6 factorial minus 2 into 6 factorial. So 7 into 6 factorial, at last what you will get? 5 into 6 factorial will be our answer here. 5 into 6 factorial will be our answer here. Always vowels not coming together means you can write it as, why? Because you can take 6 factorial common, 7 minus 2 is 5. So 5 into 6 factorial. Generally students, in examinations they will give answers in words only. That means they will solve these factorials completely. Here I am not solving. Why? Because it is waste of time. If we go on solving these factorials, it will take a lot of time. So to avoid that, I am writing only the answers in factorials. But in general, in examinations, you will have the complete solved answer. Okay, right. Next, poison. 1, 2. Is any letter repeated? No letter is repeated, so no need to worry. 3, 4, 5, 6. 6 factorial by O was repeated for 2 times, so 2 factorial minus. This is total number of chances. Total number of chances for poison is 6 factorial by 2 factorial. Why? Because O was there for 2 times. Next, vowels coming together means what we will do? PSN, OIO. Please here 1, 2, 3, 4. Okay, 4 factorial into OIO can be internally arranged in 3 factorial ways by O was there for 2 times, so 2 factorial. So 6 factorial by 2 factorial minus 4 factorial into 3 factorial by 2 factorial. Now similarly pause the video and try to get the answer for platter and corporation, students. For platter and corporation. Pause the video and try to get the answer. Platter. What it becomes? See here. First of all, in general manner, 1, 2, 3, 4, 5, 6, 7. 7 factorial ways by T was repeated for 2 times, so 2 factorial. Minus here P, L, T, T are A and E as a group. So 1, 2, 3, 4, 5, 6. 6 factorial into AE can be internally arranged in 2 factorial by T was there for 2 times, so 2 factorial. So this will be our answer. If you solve this, you will get the final answer. If you solve this, you will get the final answer. Next, similarly for corporation, please see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial by total chances. O was there for 3 times, so 3 factorial. And next, R was there for 2 times, so 2 factorial. Is there any other repetition? No repetition is there, that's it. Minus. Now vowels coming together, right? So what I will do? C, R, P, R, T, N. And what I was left with? O, O, A, I, O. A, O, O, A, I, O. Now please here 1, 2, 3, 4, 5, 6, 7. 7 factorial into this O, O, I, A, I, O can be arranged internally in 5 factorial ways by 3 factorial. O was repeated for 3 times and R was repeated for 2 times, so 2 factorial. Anyway, denominators will remain same. They will not be changed, the denominator will remain same. Why? Because based on the repetition we are writing the denominators, right? So it will not be changed. So in this manner we can find the not come together. Vowels not come together. Vowels not come together. Now next. No two vowels should come together. The next one is, in how many ways the letters of the following words can be arranged such that always no two vowels should come together. Always no two vowels should come together. Sir, what is the difference between vowels not coming together and no two vowels coming together? We will see with an example, students. For example, machine is there for me. Machine is there for me. We will see all the 3 different cases for time being. See here, vowels come together, vowels should not come together, and last one is no two vowels come together. No two vowels come together. We will try to understand the difference between these 3 things. Vowels come together means generally what we will do, M, C, H, N, A, I, E should come as a group. Always A, I should come as a group. They can be shuffled internally, but they should move as a group. Now vowels should not come together means, can I write an example? I am writing one example of that. Can I write this one M, S, C, H, A, I, N, E? See here vowels are not coming together. Why? Because A and I are here and E is here. So this is the case of vowels not come together. See, actually there are 3 vowels. In that only 2 are coming together. There is no wrong in that. 2 can come together. But this case comes under vowels not coming together. Why? Because all the 3 are not together, right? So this will be considered under vowels should not come together. Now, no two vowels should come together means, see here, M, C, H or else M, C, A, H, I, N, E. Definitely no two vowels should sit side by side or should be placed side by side. Okay, now here see here, or the vowels are together, no two vowels. No two vowels come together means this is the case, students. They should never be side by side. Any two vowels cannot be placed side by side. If in case of vowels should not come together means, if there are some 3 or 4 vowels, out of those 3 or 4, 2 can come together. There is no wrong in that. That comes under vowels should not come together. Why? Because all the vowels are not coming together, right? 2 are coming at one place and 1 is going to some other place. So this comes under vowels should not come together. and this one will be the example of no two vowels come together. Now see here students, for example, if a word contains only two vowels, if a word contains only two vowels, then this case and this case will be same. Why? Because there are only two vowels in that word. So obviously no two vowels come together or vowels not to come together will be same logic only. Okay. So if there are only two vowels in any given word, both of these are same. But if there are more than two vowels, then this one is different and this one is different. Okay, we should understand that concept. If there are more than two vowels means no two vowels come together and vowels not come together are different things. We cannot combine those two things. Understood student? So try to understand the difference between vowels not come together and no two vowels come together. Okay, right. This is the major difference. Now we will try to solve these problems. Right. Now see here students, mother. Sir, then how we need to arrange these questions? If it is on all the vowels coming together means we know. No, all the vowels not coming together means what we have done, total minus vowels coming together, that is also fine. Now no two vowels come together. How we need to solve them means, see here, out of the given word, number of word, first of all arrange the consonants. So that means what you will do, M, T, H, R. First of all arrange the consonants, and between the consonants you need to arrange the vowels. Between them you need to arrange the vowels, then obviously they will not come together. Sir, actually here I have only two vowels, but you have written 5 gaps means no problem. It can be filled at these gaps, but if the gaps are not there, they will come together. No need to worry. Sir, here I have O and E only. Yes, no problem. If I place O here and E here, these three will be in a continuous manner. That means THR we will have like this. Okay, so no need to worry much about that one. Okay. So first of all arrange the consonants. So 1, 2, 3, 4. 4 consonants can be arranged in how many ways? 4 factorial ways. Okay, superb. Now we will take the help of permutation formula, students. Now we will take the help of permutation formula in this case. Now total how many spaces are there for me? 1, 2, 3, 4 and 5. In these 5 spaces, I need to arrange how many letters? Just 2 letters. Only 2 vowels are there for me. So 5p2. 4 factorial into 5p2. 4 factorial into 5p2. Okay, understood students? In 5 spaces I need to arrange 2. So 4 factorial into 5p2. Is any letter repeated? No letter is repeated, nothing, no need to worry. Okay, next machine. See machine. M, C, H, N. How many spaces I will have? 5 spaces. See here the spaces will be one more than the consonants. The spaces will be one. Here I have 4 consonants, so I will have 5 spaces. Here also I have 4 consonants, I will have 5 spaces. So first of all 4 consonants can be arranged in 4 factorial ways into, in that 5 spaces I need to arrange how many vowels in this case? 3 vowels. So 5p3. 4 factorial into 5p3. Next, banker. So first of all arrange the consonants B, N, K, R. So 1, 2, 3, 4, 5. So 5 spaces are there for me, 4 factorial into 5p2. Why? Because I have only 2 vowels here. That 2 vowels should be arranged in these 5 gaps. Now pause the video and try to solve the remaining 3. What you will get here? Computer, first of all, as I have told you, count the consonants. Our spaces will be one more than that consonants. Or else write them, not an issue. C, M, P, T, R. Okay, so total 5 are there. So 5 factorial into, how many spaces will be there in 5 letters? 6 spaces. 6 spaces. And how many vowels I have here? O, U, E. So 6p3. 5 factorial into 6p3. 5 factorial into 6p3. Next, sister. Now see here, what are the consonants I have here? S, S, T, R. So 4 factorial. 4 consonants can be arranged in 4 factorial ways. Okay. How many spaces I will have? 5 spaces. In that 5 spaces I need to put 2 vowels. So 5p2 by, here I will get denominator. Why? Because S was repeated for 2 times by 2 factorial. So whenever there is a repetition, immediately we will have a denominator, students. Else everything remains the same. Understood? Next one. Permutations. Permutations.
Sorry.
Permutations. Try to solve the for permutations. What you will get the answer for permutations? First of all, P, R, M, T, T, N, S. Permutations. Okay, what are the letters? How many are there? 1, 2, 3, 4, 5, 6, 7. So, they can be arranged in 7 factorial into. If 7 are there, how many spaces we will have? 8 spaces. One more than that one. So, 8 spaces. So, E, U, A, I, O. So, all the 5 vowels are there for me. So, in that 8 spaces, 5 vowels can be arranged in 8P5. Sorry. 5 vowels can be arranged in 8P5 ways. By, if there is any repetition, try to write it. Yes, there are repetitions. T was repeated for 2 times. So, by 2 factorial. See students, in this permutation concept, whenever any letter is repeated, immediately, irrespective of the cases or any special case or these, that or all everything, immediately we will have the denominators. Immediately we will have the denominators. Okay, try to observe that one. Okay, next one. Now, see here, in how many ways the letters of the following words can be arranged such that always the vowels occupy odd positions. Now, here in this case, the vowels should always occupy what? Odd positions. Vowels occupy odd positions. How these things will happen? Now, please see here, in the word detail, total how many letters are there for me? 7 letters are there. So, 7 positions I will get 1, 2, 3, 4, 5, 6, 7. 7 letters I will get here. In 7 positions, how many odd positions will I get? Why? Because definitely vowel should occupy odd positions only. How many odd positions I will get here? 4 odd positions. So, whenever there is any conditions like this students, first of all we need to fulfill that condition and then only we need to go to the remaining cases. First of all, we need to fulfill the condition. What is the condition here for us? Vowels should occupy those 4 odd positions. So, total how many vowels are there actually for me in detail? Sorry, only 6 letters, right? Sorry. 6 letters. So, how many odd positions will I have here? 3 odd positions. I will have 3 odd positions. So, in detail, how many vowels are there for me? E, A, I. 3 vowels are there. So, these 3 vowels should first occupy that 3 odd positions. So, 3P3 into, and the remaining, how many are there? Consonants are there 3 and even the even positions are also there 3. So, directly you can write 3 factorial. There is no wrong in that. Here anyway there are equal number of, all are fulfilled. So, no problem. So, 3P3 into 3 factorial, which in turn becomes what? 3 factorial into 3 factorial. If you solve it once again you will get the same answer, 3 factorial into 3 factorial. Now, we will see the next one, machine. Okay. How many letter word it is? 7 letter word. Okay. So, 1, 2, 3, 4, 5, 6, 7. 7 letters are there for me. So, how many odd positions I will have? 4 odd positions. How many vowels I have here? A, I, E. How many vowels I have here? 3 vowels I have here. So, these 3 vowels can be arranged in, should be arranged in those 4 odd positions only, right? So, first of all arrange those vowels. So, those vowels can be arranged in 4P3 into, now see here, one doubt will be there for everyone. What it is, sir, out of 4 odd positions, only 3 will be filled. What about the 4th odd position? The 4th odd position will be filled by the consonant. Why? Because see here, there is no rule that consonant should occupy odd position. It can occupy if it is necessary. Definitely, see here, out of 7 positions, 4 are odd positions, yes. In that only 3 vowels are there, then anyway one of the odd positions should be definitely filled by consonant. There is no other choice. So, that means consonants can be allotted to these odd positions. There is no wrong in that. So, now first of all arrange the odd positions, vowels in the odd positions 4P3 into, now how many consonants are there for me here? MCHN. This MCHN can be arranged in how many ways? 4 factorial ways. 4 factorial ways directly, or else here After 3 positions were filled by these vowels, we will be left with more how many positions? 4 positions. These 4 positions will be filled by that MCHN in how many ways? In 4 factorial ways. In 4 factorial ways. So our answer here becomes 4p3 into 4 factorial. 4p3 into 4 factorial. Next, pounding. Pounding. Please see here. As usual, how many letter word it is? 8 letter word. 1, 2, 3, 4, 5, 6, 7, 8. Okay. How many vowels are there for me here actually? O, U, I. In an 8 letters positions, or in 8 positions, how many odd positions I will get here? 4 odd positions. In 8 positions also I will get only 4 odd positions. So first of all, 4p3. Why? Because I have only 3 vowels here. O, U, I. O, U, I have only 3 positions. Into the remaining 5 positions will be occupied by the 5 consonants by. Now I will have here by. Why? Because n was there for 2 times. So what you will write? By 2 factorial. Simple ma. If any letter was repeated, then immediately we will have the denominator. Else we will not have the denominator. Else we will not have the denominator. Understood? Right? This is the procedure. This is the procedure to find the vowels occupying even position. Sometimes if the question is consonants occupying odd positions, then what you need to do? First of all, arrange the consonants in the odd positions and then go to the vowels. Understood? Right. Next and the last question. Okay, we will see all the applications in this question. What we have understood till now, we will work here. Now, how many ways the word workbench can be arranged such that first condition is if the word start with N. So total how many letters are there? First of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So total 9 letters are there for us here. Okay, workbench, we have 9 letters. Okay, these 9 letters can be arranged in how many ways? Such that always my word should start with what? N. So 9 positions I will write 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positions I have written. Okay, always the word should start with what they are telling? It should start with N only. It should start with N only. So for this first position, how many chances are there for me for this first position? First, second, third, fourth, fifth, sixth, seventh, eighth and ninth. For this first position, how many chances I will have? For the first position, I will have only 1 chance. And what is that chance? It should only start with N, right? So 1 chance will be there for my first position. From the second position onwards, please tell me for the second position, how many chances I will have? Out of 9 different letters, all the letters are different here. Out of these 9 different letters, 1 letter N is already fixed for first position. So how many chances I will have for my second position? I will have 8 chances for my second position. Now for the third position, already 2 are locked, so I will be left with more 7. For fourth, 6. For fifth, 5. Sixth, 4. Seventh, 3. Eighth, 2 and ninth, 1. Understood, students? I hope it is clear for everyone. So for the first position, always it should be starting with N only. So first position is fixed for N. So 1 chance is gone there. So the remaining positions I have written. For the second position, I will have 8 chances. So like this, chances I have written. So what will be our answer here? 1 into 8 factorial. This one is the first position. For your understanding, I have written 1 into 8 factorial. If not, directly you can write 8 factorial. Anyway, both are same. Now, next, if the word starts with N and ends with C, it should start with N and it should end with C. Now, it means what we need to do? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 positions are there, right? It should always start with N and it should always end with C. So, how many chances are there for my first position? 1 chance. And how many chances are there for my last position? 1 chance. Out of 9 letters, 2 letters are fixed, right? So, I will be left with how many chances for my this second position? I will be left with 7 chances. I will be left with how many chances for my third position? 6 chances. For fourth, 5, 4, 3, 2 and 1. So, that means what will be my answer here? 1 into 7 factorial into 1. For your understanding, I am writing in this manner. Directly, you can write it as 7 factorial. Okay, next. The word should start with a vowel and end with a consonant. Okay. Now, see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the condition in this case? Now the word should start with a vowel and end with a consonant. In workbench, how many vowels I have here? 1, 2. Only 2 vowels are there for me, right? So that means for the first position, how many chances I will have? 2 chances. Why? Because it can start with either O or E. And it should end with what? It should always end with a consonant. So out of 9 letters, if 2 are vowels means remaining 7 will be what? Consonants. So for the last position, how many chances I will have? 7 chances. Now please observe here, student. 1 vowel was gone here and 1 consonant was gone here. So now how many chances I will have for the second position? 7 chances. Understood? Why? Because it is very clear. 1 vowel went, 1 consonant went. Out of 9, 1 are gone. So I will be left with more how many chances here? 7. Next 6, 5, 4, 3, 2, 1. So what will be my answer here? 2 into 7 factorial into 7. 2 into 7 factorial into 7. Understood? Next question. No 2 vowels come together. No 2 vowels come together. That means first what I need to do? I need to arrange all the consonants. So consonants are there. What are the consonants for me there? W, R, K, B, N, C, H. So 1, 2, 3, 4, 5, 6, 7. So total 7 factorial ways into, in 7 letters, how many gaps I will have? 7 plus 1, 8. In that 8 gaps, I need to fill 2 vowels, 8P2. Between 7 letters, including starting and ending, how many gaps I will have? Including first and end. How many gaps I will have? 8 gaps. See here, 1, 2, 3, 4, 5, 6, 7, 8. In these 8 gaps, I can fill this 2 vowels anywhere I want. So, 8P2, 7 factorial into 8P2. Next, vowels occupy odd positions. Vowels occupy odd positions. So, total how many I have letters? 9 letters are there. In these 9 letters, how many odd positions we will have? 9 positions, how many odd positions we will have? 5 odd positions. So, in that 5 odd positions, I need to fill the 2 vowels first, right? Why? Because I have 2 vowels here. 5P2 into, and the remaining, how many consonants are there for me here? 7 consonants and all are different. So, 5P2 into 7 factorial. 5P2 into 7 factorial. Like this, we are going to solve all the problems, students. Okay. Like this, we are going to solve all the problems. See here, the permutation concept is not yet done. We finished some set of questions. Later, after finishing the combinations, we will see once again the questions which are related to both our permutations and combinations, especially the questions which are based on digits. See, all the questions we have seen, all the examples we have seen based on the letters or words, right? So, next we will see the questions based on the digits, right? Thank you very much. We will see in our next session.